Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Today we are going to revise physics formulae, that is memorize physics electricity formulae from chapter 12.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
On the screen, students, you are able to see the first formula, that is I is equal to Q upon T. Over here, I is current, Q is charge and T is time. So if in the numerical, charge and time they are given, you can calculate directly, that is current I. Now if in the numerical, current is given and time is given, so you can calculate charge. But with the help of this king formula, from here you can also create a new formula which I just now told you to take out the charge. So from this king formula, charge can be created. That means the charge formula you can create. That is how? That is you will cross multiply, that is current with time, and the new formula will be created from this king formula. Okay, let us go to the next one. V is equal to W upon Q. V is known as potential difference. Q, you already know, it is a charge. And W is known as work done. If work and charges are known in the numerical, you can calculate the potential difference, put up this formula and quote the values, and you can calculate the potential difference. If in the numerical potential difference and charge are given, then you can calculate work done. Now, how to create the formula for work done? Of course, from this king formula, we can create a new formula, that is of work done. So from here, work done is equal to cross multiply potential difference into charge. So this is the new formula created by this king formula. So over here you are seeing, children, that from the first formula, which was known as king formula, you created another formula which was a demand in the numerical to quote the value. So you created from this king formula. Second, that is this formula was created from this king formula depending upon the demand in the numerical. Okay, let us go to the next one. V is equal to IR, that is from Ohm's law. We know that V is potential difference. I already we know, that is current. And what is this R? R is nothing but resistance. So this is the new formula, that is from the Ohm's law. V is equal to IR. Even you can remember this formula with a trick. That means if you remember one, the name of a boy, say Veer. Yes, I repeat, name of boy, that is Veer. So what is this? If you remember the name V, so V is equal to IR. This is the Ohm's law. Got it, children? So this is the trick to memorize the formula. Okay.
Now we are going to do Ohm's law. Ohm's law is nothing, but it is a relationship between voltage and current. Now we know that V is directly proportional to I. Now, to remove this proportionality sign, we will introduce a constant which is known as R, that is known as resistance. So, we will have the expression as V is equal to Ri. So, R is the proportionality constant called resistance. And resistance is nothing but opposition to flow of current. This you have to keep it in mind, students. Now, we can also take out the expression from this king formula as, that is I is equal to V upon R. Or if we want to find out the resistance, we can also find out as R is equal to V upon I. So with the help of this king formula, we can create other formulae also according to the demand in the numerical, whatever is asked in it. Now, we can also write that R is inversely proportional to current. So this is the expression, we also know it. Now, if I say that if R is increased twice, so what will be about current? That is, if R is increased twice, current is also reduced to half. So always keep it in mind some concepts which we are doing it in this chapter. And these kind of conceptual based questions can come in your exams. Okay. Now let us talk about resistance. Now resistance, as I told you earlier also, so there are some factors, that is resistance depends on some factors. What are these? Let us do it. Now we know resistance is directly proportional to L. L is what? Length. And resistance is also inversely proportional to the area of the conductor. Okay, fine. Now if we combine these two expressions, we get this expression. That is R is proportional to, that is L over A. To remove this proportionality sign, we will introduce a new factor which is known as rho, or we call it as resistivity. So this is the proportionality constant rho which will be introduced to remove proportionality sign. So the expression becomes R is equal to rho L upon A. Or we can also find rho according to the demand in the numerical if they ask. So the expression becomes from this, that is the king formula, that is rho is equal to RA upon L. So this way we will come to know about the expression, whatever we have to find out according to the demand in the numerical. The next one is, that is R is also directly proportional to T. What is T? T is temperature. So if temperature increases, resistance also increases. And R is also directly proportional to the material. That is, the conductor is made up of which material? So that is the conductors, resistors and insulators. So in conductors, the resistance is minimum. In case of insulators, resistance is maximum. And in the case of resistors, we can say it is between conductors and insulators. That is, somehow it is in between. That is medium. That is, resistance is medium in resistors.
If the resistors are in series in the circuit diagram, the formula becomes Rs is equal to R1 plus R2 plus R3. It can be more than 3 children, but I have taken 3 to tell you, but it can be more. So this is resistance, that is the in series. Now if it is in parallel, that is Rp in parallel, 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on and on. So this is resistors when they are in parallel. This is the formula used to calculate the answer. Okay, children. So these are the two, that is in series and parallel. Next, P is equal to VI. We are doing about the power now. Okay. So P is equal to VI. Now, what is this P? P is known as power. What is this V? V is known as potential difference. What is this I? I is known as current. So all the three we are aware about it. Now, we have written this formula P is equal to VI, and we also know according to Ohm's law, we know V is equal to IR. Correct, children? So what we will do? We will put the value of V is equal to IR in this first formula, and after putting the value, we get V, that is the P is equal to I square R. How we got this? That is after placing the value of V is equal to IR in this. That is, instead of V, I have put IR. And after that, I got a new formula, power, that is P is equal to I square R. Okay. Now, seeing this Ohm's law, I can also create a new formula, that is I is equal to V upon R. Yes, this is what I have written over here. That is I is equal to V upon R. When I know this value, I can place this value in this formula, which I have written it over here. So what I will do, this V will remain as V. Instead of I, which I have taken out over I over here, and the formula comes out to be V upon R, I will place the value instead of I, that is V upon R. After this placing, I get a value of V square upon R. So that means I got the third formula for power. So in this case, what we did, we got 3 formulae for power. Okay, children. So this was the king formula. Quoting the value of V is equal to IR in this king formula, I got a new formula, P is equal to I square R. And then after creating a new formula from Ohm's law, I have put up the value of I is equal to VR into this king formula, and then I got V square upon R. And in this way, we got 3 formulae for power. Whatever is the demand in the numerical, I will see what is given in the numerical. I will code the value in the formula, but which formula to be used depends upon the numerical, what they have given and what they have asked. After quoting the value, simplify your calculations and take out the final answer. But remember, for the units, children, units, please do not forget to write. Okay, so this tells us that we have 3 formulae for power, 1, 2 and 3. Okay, now H is equal to VIT. Okay, H is what? That is energy. Energy, we know it. That is energy. We know that is, it is also equal to P into T. Now what is P? P is power. What is T? T is time. Okay. Now we also know that this is H, which is known as heat energy, is equal to P into T. Right? Okay. Now we also know, which we have done it just now, few seconds back, P is equal to VI. Just now we did. When we know P is equal to VI, what we will do? We will quote the value of P is equal to VI in this formula. That means instead of P, I will write VI. So after quoting the value of P in this, I got the formula finally this. That is H is equal to VIT. Got it? So this is the formula that is for the heat. And one more, that is H is equal to I square RT. This is nothing but the Joule's law of heating. So these are all the formulae for chapter electricity, chapter 12, how to solve the numericals with the help of these all formulae. It should be there always on your tips. Whatever is the demand in the numerical, see the values, what they have given from that is the king formula, create your new formula according to the demand in the numerical, quote the values, see the units. If the conversion has to be done, please do it. Quote the values, simplify your calculations, take out the answer. But after writing the answer, the unit should also be there. Otherwise, the marks will be deducted. Clear, children? So please revise these formulae again and again the way I have told you in sequence, and you will never be wrong. In this way, there will be no error in your numerical. Your numerical will be absolutely correct. That is gaining full marks. Okay, children. So with this, I wind up the session. Please subscribe the channel if you like it. Share it with your friends. Sharing is caring. This chain reaction of sharing the AcadShala link should not stop. Please help each other. With this, I wind up the session. Bye-bye. Thank you. God bless.